for you at the moment.
Wonderful. It's a nice community to be a part of.
Yeah.
Please take it away.
Thank you.
Hello, good afternoon, everyone. As Jonah introduced, I'm Qian Sun from RMIT. So I have been trying my best to enhance our teaching curriculum to following the industry demand. So as Paulina introduced, like 3D Hong Kong, there's API things, there are a lot of the AI things, so give a lot of challenges for university lecturers to update their teaching material and to apply for real-world applications. So today I'm going to report with my two teaching team, two PhD students, to introduce a few awesome cloud-based open-source GIS applications from our RMIT students. So we will cover why we move from the traditional one-tier GIS application to three-tier, multi-tier, to focusing on the S in GIS, which is a system. So it's an emerging paradigm from the analyze-based to a system development. And we used this kind of idea of scaffolded project-based learning theory, which is a pedagogical framework as teaching students from tool user to tool builders. And they learn to think about how to conceptualize the system using the three-tier idea, which bridging the data and the logics and the interface layers, and apply to real-world problem. So to tackle real-world challenges with the open source GIS approach, I'm personally is a big fan of open source data, the happy data, and the open source, the happy tools. And we will have to teaching team to give you an overview of students' apps, and we'll have students to talk about their projects in the video. Okay. So what are the challenges we are facing as a university lecturers? So we have seen rapid advancement in geospatial technologies, driven by, for example, cloud computing, big geospatial data, real-time monitoring, a lot of Internet of Things, APIs, so make it a fast evolving and dynamic field. So the challenge for us is how to bridging the gap between theoretical knowledge, fundamental geospatial theories and the real-world applications in order to prepare our students to adapt to industry demand and not of skill shortage. And eventually we can help to tackle the complex real-world environmental social problems. So what is, I quickly just touch on what is a scaffolded project-based learning, so which is, teaching students from a small thing and gradually build their skill and their technical understanding to implement a project. So which combine the project-based learning theory for active and hands-on education. So in university tertiary science education is to encourage students to progressively to solve real-world problems with supported by gradual step-by-step incremental guidance. So there are some theories behind that I probably just quickly, because we have a lot of things to cover. So we use the constructive theory. We use the critical thinking of Bloom's pyramid, and we mentor students with the peer assessment and the self-reflection in the semester-long teaching period. They gradually implement the individual project with the step-by-step skill learning. Okay, so I'm not touching on this slide. So how we design that? So students do the project and the learning from project scoping in the first week to the final report in the final week. So they built a cloud-based GIS system step by step, integrating back end and the front end, and they apply that into a real-world application and using this active learning theory. So they conceptualize the system into the 3 tiers. We will have one way to introduce that. And then we teach them for the open source tools and help them to find the open source data. And during the time, they reflect their learning process, and they got peer assessment to help them to troubleshooting, solving problem. Eventually, they got the project done. So let's move on to how to conceptualize the system design with the idea of 3-tier architecture. I'm moving to Wenhui to introduce that.
Okay, thank you, Chen, and hello, everyone. So I just jump into quickly introduce our idea of like 3-tier architecture. This one is the, this might not working. So, okay, this part is the 1-tier system, like it's the left one. So it's keep everything in one place, which is simple but limited. So currently with all sort of resources and open tools available, so we're moving from the 1-tier framework to the 3-tier framework, moving from the local-based to cloud-based. So which this architecture allows for more flexible and scalable and also easy to maintain, allow multi-users to access and manage. So, and it's especially suitable for cloud-based geospatial web application. And we're trying to start with teaching students from the back end, like using geospatial database, how to manage the spatial data properly. And they work with like Postgres GIS to store and organize data, and that they retrieved from the open source official data hub or from like a Google's engine data catalog, and analyzing those data by like processing the data using like QGIS things, and then move to the internal or external gateway to host and transfer the data into front end, like some of them use the WebGIS web server, map server, and also the backend, they trying to develop the UI and think about how to present or visualize the data and interact with the users. So yeah, so here's the list of the topics they are trying to use. So they all start with identify a real world challenging that we or a problem they're trying to solve. So this slide shows the range of the real world challenges they are choose to work on, and some, for example, like urban heat, air qualities, or like real-time transportations, or some like ecosystem change, or land cover, land use things. They're trying to identify a meaningful problem in their community or environment. And across all these topics, the starting point is always the same, like students begin by observing something real that related to their life, and from there they frame a question and gathering data and based on their problem and apply the 3-tier geospatial workflow to build an analytical and or visual tools that address that real-world issues. So the topics you see here represent not just academic exercises, but problems students genuinely want to solve. So next I will pass to another tutor, Xinjita, to introduce more detailed project. Okay.
Thank you, Wanhui. So now that you have heard that what we teach and develop in the 3-tier architecture, I will present some of our students' web demo on what they have built and learned over the course. So here you can see that we have a demo of a student using QGIS to web plugin. Oh, yeah. So it's edited in the video itself, and the main innovation of using this open source tool is not just the plugin helps to bring out the static web map, but we teach them how to make it interactive. So by adding different APIs and seeing real-time feeds and how to make a good dashboard out of it. And next, moving to another example of QGIS to web. So we see here that how the students have developed a clean and nice web visualization from QGIS, using QGIS to web plugin. And this, one of the best thing about this plugin is that it generates in JavaScript, HTML, CSS, which helps us to modify it and change it to make the map more interactive. And with this, you can see that how the map, like we have added, the students have added the interactive dashboard, drop-down filters, dynamic layers, and it can switch between different layers and see how the UI components come together into one to create a clean, data-driven analytical tool and a web application. Next, here is an example of a web application built from using Google Earth Engine. So previously we have seen that how the database is from PostGIS to QGIS and then developed to the web using QGIS to web plugin. But in GEE, everything is integrated into one platform where we have the data layers and the processing layer in the backend, and then student kind of use the GE coding to kind of develop the front-end web application. So, so if you play the video, so you have seen how the student have used this GE to develop a LST, NDVI, and NDVI dynamic temporal map for Melbourne, and we have the split view on the screen where we can see the different land cover variables on each side of the map, and we can also control the opacities of the layers, and we can also see how the temperature and NDVI and NDBI has changed in Melbourne. Next, we have one example for us from a student who have actually implemented a full stack GIS architecture, which we focus actually on teaching to bring everything under one ecosystem. And on the back end, you can see that the student have processed the data in QGIS, stored it in PostGIS, and the data set was then served through GeoServer, and the whole system is running on Ubuntu AWS server, and then it was developed using web open layers to deploy our open map for, but the whole innovation of this project lies in how we can put everything on cloud server so that it's accessible for users. And next we have, of course, our students can't come and present, so we have tried to kind of make a compiled video of some of the project's demo, but in interest of time, I'll try to kind of fast forward some of the parts.
Yeah, so this is building a cloud-based GIS web application for monitoring stream safety and surf quality across New South Wales. Oh. So how do we do this? We do the three web architecture. We have our backend, our database, which holds these three APIs, and then we combine those three APIs into one data frame, and we place that into our PostGIS. This is then, as I said, into our GeoServer, and then we fetch it using our link web application. And then this is hosted on GitHub. So this is our water quality beach application. When we see the pollution rating, obviously right now it's very good to swim because all these have very good pollution scores. So we can search a beach, we can search Bondi, and it zooms in, and it also has rainfall. The reason I added rainfall in is because it correlates very heavily with the pollution score. Normally with more rain, there's more pollution, and that's for sites where forecasters aren't available, you can still derive some sort of pollution score without having the Beach Watch API. Likewise, then going on to our surf quality, this is how good the surf is during the day. We see these variations across the time. We see that there's some of the best sites are in these uppermost part of New South Wales. So ugly, and every score has a score from 0 to 10. This one is one of our best at 5, and we have our scores here, which these are what create up 4 of 10, these values here. But yeah, that's...
I'm Peter Kuselinas, and I'm presenting what I made, which is heat vulnerability in the Darebin area interactive maps. This is the workflow that I followed. I got most of my data from the Australian Bureau of Statistics, from Table Builder, census data for vulnerability and for the languages spoken, and also for the vegetation cover. And in terms of heat, I got the data from Google Earth Engine with Landsat. I went on to PostGIS and then QGIS, where I changed everything into maps, and then QGIS to web product. So as you could see, there's 2 different maps. One is the called percentage map, which shows the percentage of culturally and linguistically diverse areas. And when you click on each one, it shows data about it, what the SA1 code is, where it is, and the top 5 languages spoken. And then the second one is heat vulnerability index and tree cover percentage. So if you click on it, you'll see the heat vulnerability and also the tree cover. So here it's 6.297% tree covered, and it is a 0.4 on the heat vulnerability, so about halfway through. And it also has information about vulnerable people. So there's 29 people that are 0 to 4 years old, 81 people that are 65 and over, and 37 that need assistance with everyday life. I've also put a small chat bot here. So if you have any questions or you're unsure about anything that's on the website, you can ask something. So say you don't know what LOTE means, you can just write LOTE and we'll tell you what it is.
Hello everyone, my name is Wilson and I'll be presenting my application, which the core idea is to show the gap between the household income and the price of houses and apartments here in Melbourne. So this is the architecture for my project. It's simplified, but it started with the CSV data that I've collected from the Australian Bureau of Statistics, from DataVic, and then I tried to process everything to local database, which is the Postgres, and then analyzed, let's say, run a few analyses with QGIS, and then I took everything to the online cloud database, which is called Superbase. It's free to, depending on the tier of usage, but for the one thing, for this application, it's free. And then I moved everything, connecting with Mapbox, using JavaScript, HTML, CSS, and then deploy using GitHub. This is the application. So right here, let me quickly show you. As you can see on the left side, there is an income, house pricing, units, and as you change one layer to the other, it will calculate
I'll
automatically.
try to fast forward it due to time, but
Gap between the household and...
I'll just bring up the page if possible. Okay. So here...
and then I have any of this server.
CesiumJS, and the game is
A small
to the other, it will right up.
the project aim is to have a 3D replica of Melbourne, and we do it through CesiumJS and Cesium Iron. And then the real-time data comes in from the Open Data Transport APIs. And the goal is to visualize trade movements in real time and also have an interactive interface in which users can click on trains, or they can get data as they require. Very simplified version of how it works. So we have the desktop QGIS where I did all the lines and the stop manipulation, and then I put it on Cesium. And then from that on, I have a middleware server, and then I have a front-end Node.js application. So the goal of having a middleware server, that's Express.js server, what it does, it gets it from the API, fetches the data. So this is the app running in real time right now. So for the base map right now, I'm using OpenStreetMaps. You can choose it from over here and change it. So we have Flinders Street over here, and you can see blinking over there. So this is real time. What's happening is trains are basically trips. So trips are being added, and they are removed every like 20, 30 seconds. So right now, one of the trains, you can say, sort of dying. It's being removed, you can say. And then I can click on, and I can see where this train
I do have to
is heading.
go back to
So-
kind of to this. So,
Whether there's GeoServer as the middleware and Mapbox, how to use the product. Farm, you can click on that property. That process right now is as the middleware and that presents a button. There's some tool tips on the right to help you understand how to use the product, which are foldable. You select a property, so the pasture farm, any change index data that is relevant to that property is available. You can click on that property and you can begin to view some change detection results. And they're coloured according to whether there's positive change or negative change compared to that paddocks norm.
Created the front, so anyone could jump on data. So this is the current front end, and I'm just going to take you through what's happening here. It looks simple, and that's for a reason. I really wanted to make this accessible so anyone could jump on here, click around, and understand what was happening. I've created just 4 buttons up here just to give you some more information. I've got 3 different buttons here. These are all connected theoretically to the Melbourne Water API. You can collect them independently. You can click one at a time, go have a sandwich, come back later. It doesn't matter. They're not really related except for the final button. So just click these so you can get an idea. Theoretically, this should show the real-time rainfall and river levels. And then down here, this button uses the data from those 2 APIs to theoretically calculate the flood extent. So at the moment, no flooding detected. But let's just have a little bit of fun. And climate change is coming, so we need to worry about these kind of things. For major flooding, and I know it doesn't look that big on the screen, but if we have a little zoom in, this black line indicates the current flood buffer.
okay. Thank you. Now I'd like to pass to Chen to kind of conclude the
final. Thank you, everyone, for your patience. Thank you. So, oh, no, not that one. Thank you for the patience. So, so that's 5 examples of the projects. The students pretty much move away from the traditional GIS, study to this kind of developing a system. They understand that what is a back end, how to develop database, to how to deliver the system as a front end, use all sorts of tools. So we have this LinkedIn account for everyone interested to reach out me or teaching team for potential students projects or any collaboration, including digital twins or climate change monitoring, Google Earth Engine application development, and potentially, ESG. If you're interested to enroll in RMIT, welcome, Jonah. And we are happy to answer any questions. And now or outside the session or even after the conference. Yeah, thank you.
Any questions, please? I have a question. Were these undergrad students that made these projects?
Really good question.
That's really impressive. In my undergrad, I was not doing this. Any questions, please? Would you please join me in thanking our presenters and the students? They did a great job, right?
Thank you.